Hello everyone, this is Yunfeng Ruan. I'm going to introduce how to calculate polygenic risk score with PRS-CSx. PRS-CSx combines multiple GWAS to increase the accuracy of polygenic risk score. If you are interested in the algorithm, please refer to our preprint on medRxiv. Our GitHub has a very detailed README that covers almost all the aspects of how to run PRS-CSx. If you are familiar with Python, you may figure out how to run it within no time yourself. Here, I will walk you through the whole process and clarify some details in addition to the README. This is the workflow of the method. The input is GWAS summary statistics from different populations. PRS-CSx adjust the effect size of each population GWAS using their corresponding LD reference panel. The adjustment of SNP effect size are performed to SNPs that are shared by input GWAS, LD reference panel, and the target data. Therefore, PRS-CSx needs the prefix of target data so that it can read the SNP list from the .bin file. The output is two sets of adjusted effect size. Next, you calculate the PRS of your target sample based on each set of the adjusted effect size. Usually, this is done by Blink. Finally, you linearly combine the PRS from different population GWAS using software like R or MATLAB and predict the phenotype with the final resulting PRS. You can also add more GWAS so that hopefully you can have a better result. Now let's see how to run PRS-CSx step by step. PRS-CSx is a command line Python software. You can use either Python 2 or 3 and have to install SciPy and H5Py. You can use command git clone to download and install in one step, or you can click the code button to download it locally and unzip the compressed file. You can test if the installation is successful by command PRS-CSx --help. It will print a long list like this. Next, download the LD reference. We provide the pre-calculated LD reference panel link at the README Getting Started session. We have LD reference calculated from 1000 genome and LD reference calculated from UK Biobank samples. You also need to download the SNP information and put it in the same directory with other LD reference files. After you download all the software and the LD reference, you can run your first analysis. You can download the formatted test data and use the example command from the README test data to run the test. The test will be finished in about 1 minute, and you will have 2 txt files as the output. If you use your own data, the first thing to do is format your summary statistics file. The information is available on using PRS-CSx session. I want to highlight that the formatted input must contain header line and have the right column order and the variable names. Now you can finally run the method. Here is a typical command, which contains the path to the PRS-CSx. The the directory of LD reference, the prefix of the target data, a list of formatted summary statistics. Please note that you put a comma between different items and there should be no space in the list. And the list of GWAS sample size and the list of population of the GWAS. We highly recommend you run the PRS-CSx per chromosome to allow calculation in parallel. You can specify which chromosome you want to adjust by specifying it in the Chrome option. And then the hyperparameter phi and the output. To adjust the effect size of one trait, you need to run 88 jobs. For each job, PRS-CSx will print something like this on either stream or the log file. You will get two outputs, one for each population. If you adjust each chromosome in parallel, you can concatenate the result in one file. Use the command cat. Altogether, you will have 8 sets of adjusted effect size. You can calculate PRS based on the adjusted effect size using a allelic score function in Plink. The last step is to predict the phenotype with the PRS. First, you normalize all the PRS to mean equals to 0 and the standard deviation equals to 1. Then you optimize the hyperparameter in validation data. For each phi, you predict the phenotype with the normalized PRS-A and the normalized PRS-B and get the R-squared. You compare R-squared from each phi and learn the best phi and the coefficient of the two PRS under that phi. Then in the testing data, you calculate the final result. With the knowledge of the best phi and the coefficient of the two PRS, you choose the PRS under that best phi and combine them with the learned coefficients. Then you use the combination of the PRS to calculate the R-squared. This will be your final result. If you have any other question, you can raise an issue on the GitHub website. We thank Hailiang and Tian to supervise this project and all the team members and the data resources.